Hi, this is Mr. Frazier, and I'm going to go through you step by step lesson 3-2 assignment. This is like a sample problem. The reason why I'm going through this is because it takes one situation and does all the things that you will practice in your skill practice. So we're going to do one situation, and I'm going to do it with you. Hopefully you follow along and you write some notes onto it and add it to the things that you need to do. Okay, so when we're reading this, it says Mr. Johansson is a history teacher at Franklin Middle School. He gives a class a 50-question multiple choice test. Each correct answer is worth 2 points. So that means it's 2 points per question. Okay, so that's our first correct rate of change. So 2 points per question, which would be my 2x. It says while a half point is deducted. So the word deducted means to subtract, and a half point is 0.5 or 1/2. Either one would be acceptable. And it's 1/2 y. Why is it 1/2 y? Because you're deducted 1/2 a point for each incorrect answer. So your incorrect answers are your second independent variable. All right. Now, if I wanted to write this in a function notation, most of you know that you would then write f of x of y. And the reason why we do this is because we actually have two independent variables. And we can also change the order of which this problem is too. We can move it around. We're going to talk about that in just a second. So it says, determine the test score of a student who has 30 correct and 5 incorrect. Show your work. Okay, so we know x is the correct. So if we want to, we can write it in function notation again, if they asked us to. They didn't ask us to, but we could write it in function notation, which would be here. Okay. And it means that 30 gets plugged in for x, so we would do 2 times 30. And then they said minus 0.5 for every wrong, so we would put 5 in here. Now we go through step by step. 2 times 3 is 60, minus 1/2 of 5, which is 0.5 times 5, or 5 divided by 2, which is 2.5. When I subtract those two, I get, what do I get? Correct, 57.5. That's what I would have scored on the test. So if you know the number of correct answers, are you able to determine the number of total points each student earned? And we talked about this one in class as well. This was part of our in-class textbook work. How many variables can you solve for at one time? One at a time, correct. So if they don't give you 2 of the 3 pieces of information, you can't solve. You need 2 of the 3. You just can't have one. Okay, you can't have the number of correct answers and then be able to give me the correct score because you're missing the number of wrong answers. All right, so the answer would be no. And you can't solve for 2 unknowns at the same time. So that means you can't have 2 things missing from a problem. Okay, and we call those unknowns variables. You can only solve for one variable at a time. So that means sometimes we're going to have to reorder the problem. So we can look for different things to see if we can make a relationship from something that is 2 independents. Okay, so let's look at it. And here is our next question. It says a student needs to earn 80 points on the test in order to keep an A grade this semester. So that means now we're going to write an equation. The unique thing about the equation is now we have the answer, correct? So we have 2x minus 0.5y equals 80. That's the score we need. Now, that's only part of the problem because they want us to write the equation in terms of number of incorrect answers, which means I need to know, or they're trying to force you to tell me, that incorrect answers is the dependent. That's what they tell you. So that means you need to get this by itself. So that means we have to change this form into slope y-intercept. Well, how do I do that? I move the x first. So anytime you move an x over the equal sign, it becomes its opposite, right? So here it's 2x. When I move it over there, it's negative 2x. It means everything else on the left side stays the same. So the minus is still there. 5y, or 0.5y, equals negative 2x plus 80. Excuse me. Now I have to divide this whole problem by what number? Negative 0.5. Now if you wrote this as negative 1/2, you'd have to get rid of that fraction. And of course, to get rid of that fraction, we would multiply the whole problem by, correct, negative 2, the denominator. So it's similar. You have a calculator, you should be able to figure this out one way or the other. So if I divide everything by negative 0.5, I get y equals negative 2 divided by negative 0.5. Two negatives make a positive. Plus, again, it would be a negative and a positive make a negative, plus a negative 160. Now remember, this negative 160 is where we start. What is that called? The negative 160 is the y-intercept. Okay, so that brings us to our next thing, the y and x-intercept. And we said this in our notes yesterday. I put it on Portal as well in a picture. It was an addition to the notes. And it says that in order to find the intercepts, if you want to find the x-intercept, you must put a 0 in the opposite coordinate. So, what's the opposite of x? Y. Okay, what's the opposite of y? X. So if I'm looking for the x-intercept, that means I put a 0 in the equation for y, correct? So in other words, they want you to do two problems, an x-intercept and a y-intercept. So I put a 0 in for y the first time, and then the second time I put a 0 in for x. And I solve for both. So first I move 160 over, equals 4x. X equals 40. Which means in order for me to get an 80 on this, I must get 40 right. So here's x equals 40. X equals 40. Okay, here we go. We put y-intercept. Well, there's two ways you can do this. You can always plug in the number, but you automatically know that the y-intercept in slope-intercept form is that last number, which is negative 160. So that means you automatically get one of the two, x or y-intercept, just by putting it in slope-intercept form. Then, of course, you take your straight edge, ID, whatever you have. All right, so what I've decided to do, as you can see, is I'm going to go through Skill Practice 3.2 real quick and go over the problems that already have the answers. So here we go. A farmer's market sells apples for 75 cents per pound. So that is our first rate of change, correct? And oranges for 89 cents per pound, which is our second rate of change. So because we have two rates of change, we can write this as a standard form. So we can put 0.75x, right? Because every time we see the word per, we can put an x. Well, we see per twice, so now I can put a y. Or in this case, they use A for pounds of apples and B for pounds of oranges. Anybody want to take a guess of why they don't use O? Hopefully you know they don't use O because O for oranges looks like a 0. So I just say use X and Y every time. There's no reason why not. And this would be the expression. Remember, we're writing an expression, not function notation and not an equation. Okay? And you'll do that for the rest of problems 1 through 6. We get to problems 7 and on, and here they want us to define the variables, which is what we were doing in the beginning, and then they want you to write an equation for each situation. So a florist sells carnations for $10.99 a dozen, $10.99 per dozen, and lilies for $12.99 a dozen, $12.99 per dozen. Again, 2 rates of change. So I can make this one X and this one Y. Or carnations and lilies. I just like using X and Y all the time. It's okay if you use X and Y. So X would be carnations and Y would be for lilies. During the weekend sale, the florist's goal is to earn $650. So now we're going to write an equation. So you'd have $10.99X plus $12.99Y equals our $650. Relatively easy. So we started by assigning variables and writing an expression. Now we're going to assign variables and write an equation. All right. So that's all the way up to problem 13. Problem 13, they say, now we're going to not only write an equation, but we're going to find the value. So here we go. Basketball Booster Club runs a concession stand during the weekend tournament. They sell hamburgers and hot dogs. So here we go. $2.50 a hamburger for each hot dog, or excuse me, for each hamburger, and $1.50 for each hot dog. So $2.50X, $1.50Y. So when you add the two together, you're hoping to earn $900 for the tournament. And they even give you the equation. So we're going to use this equation to find the unknown amount. We should have been able to write the equation, but they even gave it to you. So now if the booster sells 315 hamburgers, so now I'm replacing the X, which is hamburgers, and I'm putting in 315, and then I'm going to solve to see how many hot dogs. Then of course, my answer is in a sentence. The Booster Club must sell 75 hot dogs to reach their goal. All right. Now, if this had come out goofy, like 75.2, that would mean they would have to sell how many hot dogs? 76, right? Because you can't sell half a hot dog. Someone might get a little grossed out. All right. So we're going to move on, and we're going to look at problem 19, because that's when we switch again, and we do something different. And in problem 19, they say determine the y and x-intercept of each equation. So remember, to solve for y-intercept or x-intercept, we can use either form. It doesn't matter which form we use. And if we want the x-intercept, we put a 0 in for y. Correct. We put a 0 in for the opposite of what we're looking for. And if I need the y-intercept, I put a 0 in for x. So here we go. There's the equation. They put a 0 in for y, which means I'm finding the x-intercept, which gives me x equals 12. Okay, that means on the x-axis, x is 12 and y is 0. And then when I put a 0 in for the x, I solve, and I'm going to get y is 30. And you can see the equation here on the math that you're doing. And if the y is 30, that means the x was 0. And you'll do the same for all of those, finding the x's and y's. Okay, then we move on to the graphs. And just like the assignment we did, you're going to solve for x-intercept, y-intercept, and then you're going to put those dots. So if it was, in this case, you put a 0 in for y, you solve for x, you get x equals 18, so I put a dot at 18. Put a 0 in for x and solve for y, I get y equals 15. So y-intercept is 15, x-intercept is 18. I put the 2 points, I use a straight edge, and draw a line. I can do this for every problem. Okay. Whether it's in standard form or slope-intercept form. Now, when it was in slope-intercept form, we learned a shortcut as well. We know that this number right here is the what? Correct, y-intercept. So we can already put that dot because we know what the y-intercept is. Okay, it's negative 15. Now if I put a 0 in for x, I'm going to get the answer y equals negative 15. Either way, you should know what the y-intercept is. It's the x-intercept that's going to be a little tricky because you got to put in a 0 for y and then do the problem solving. All right, and then you have to graph. That means you have to come up with your own intervals. So on and so forth. And that is it for 3-2. And you draw your line. Okay. All right, so let's flip it over. Continue. They want to know what is the slope of the graph. And when you changed it, the slope of the graph was the form. Okay. Which means we had it in y equals 4x minus 160. The slope is already there, which is 4. Now, mathematically, you could solve for the slope. So you take your y-intercept and your x-intercept. Let's go ahead and do that. The x-intercept was 40, 0. And the y-intercept was 0, negative 160. Okay, so you have your x, your y, your x, your y. And the slope formula says subtract your 2 y's. Actually says y2 minus y1. So that'd be negative 160 minus 0. And then x2, x1, which would be 0 minus 40. Hopefully you see that's negative 160 over negative 40. When you divide those, you get 4. 2 negatives make a positive. Now, you can do that math, or when you switch it over, you can remember that the slope is in front of the x. All right, so the next thing says, if the student had 43 correct answers, how many were incorrect or not answered? Does your answer make sense in the context of the problem situation? If not, what numbers of correct answers and incorrect answers do make sense? So that means we've now changed this equation, and they want us to plug in 43 for the number of correct answers, minus 160. So now I do this, I get 172 minus 160. Okay. And we know the number incorrect, if you got 43 correct, the number incorrect would be 12. Because y stands for the number incorrect, and there it is. So if we got 43 answers correct, we could get 12 incorrect and still get a B in the class. And do those answers make sense? And hopefully we understand that they do make sense, because if each question is worth 4 points and each wrong answer is worth minus a half, that means you'd have to get 4 wrong, and that would be 2 points. Okay, and we keep going up until we get to a number that makes sense. Now let's go back to E here, and it says what does it mean in terms of the problem situation? That was the only thing I didn't address. Which means, what do those x and y intercepts stand for? And what does the slope stand for? Well, the slope stands for every 4 points, excuse me, every additional correct answer, the number of incorrect answers will go up by 4 in order to still have an 80. Okay? So I'll try that again. When you have the slope of 4, it means that every additional correct answer, the number of incorrect answers will go up by 4 in order to still have an 80 on the test. All right, so being able to switch forms, being able to substitute in, write an equation, solve for a different variable, and we're basing it on scoring an 80. So that's the only reason why we're able to do this. If you didn't have an answer for this problem, you couldn't write it in standard form, and then you couldn't change it. The idea is making sure that you write it in standard form, and then you would have to rearrange the problem. All right. Thank you very much for listening, and good luck on your homework. Your homework is little pieces of each one of these things. Remember to make sure you look at the odds to see what the answer is supposed to look like. That is both the math and the sentences. Remember, because we're practicing writing our sentences in terms of the problem. Good luck, and hopefully you come to class with either questions and or the work finished. Thank you very much. Have a good night.